Hi everyone, welcome to another video. Today is going to be extra special because I have roped in someone fantastic to talk to on the channel to tell us some interesting and amazing facts about something that I haven't really covered on the channel before. And double whammy, you're basically going to get two Elizabeth today because her name is also Elizabeth. So it just feels like it's a whole extra awesome episode. Without further ado, welcome Elizabeth 2.0. Elizabeth Beston, welcome to the channel.
Hello, Elizabeth 1.0. Original Elizabeth. We should start a cult of Elizabeth.
Yes, it does feel like we just started a. Yes, I'm only having Elizabeth guests from now on.
No, that might reduce your pool of guests.
Yes,
somewhat.
It's not really the name of why. It's not your name that's brought you to the channel. It is your amazing marine knowledge, but it's just an added benefit. I'm just going with it.
Absolutely, I think you should invite the Queen on, see what she knows about
there we
marine
go.
life.
Lizzie 3.0. I don't think we can.
I don't know if she'd appreciate that.
Yeah,
I'm the original. No,
yes. I'll be bumped down.
No OBE for you. That's it. It's gone.
Oh, brilliant. Well, welcome to my channel, the digital world of marine mumbles. I just, before I asked you to introduce yourself a bit more, your Instagram is just fantastic, and I want to say that it has brought me so much joy in my life and during the lockdowns and everything, because you've been posting and we've amazing digital connectedness, and it's great that we now get to connect online through this, and you now get to connect with everyone that follows and subscribes with my channel, and I'm just so excited. I feel like it's like a big giant coffee meeting where I'm like, look at this amazing person. Which is really fantastic.
Stop it. It's very kind of you to say.
Yes, well, I mean every word. So without, I suppose I should let you introduce exactly what it is, since I've been going on about it so much.
Well, I'm going to be talking, or we, the cult of Elizabeth, is going to be talking about diatoms today.
I'm so excited. You have a very good t-shirt to show that. They are not that size in real life, however. That is definitely
not terrifying.
It would. Oh yeah, it would be terrifying. Good to swim through, maybe. I don't know.
It might be a bit sharp. Quite a lot of them got spiny bits, and essentially they are made of glass. So it might be.
Okay. Yes, that is true. Good Instagram photos, though.
Might be amazing.
The cover of Vogue would have diatoms on for sure. Hello.
This is not a diatom. This is a cat.
Is a very cute cat. Yes.
Of course, because everybody watching this is only interested in marine animals. So this is a land animal.
Oh. But a fluffy land animal, so that's fine.
Yeah, so I'm sorry if my table rocks because he's just about to do something. What are you going to do? No? Okay. Right.
We can't expect Gallifrey to not be on screen. He's got to have a little cameo at least. That's
good. He's gone now because he's adding his extra body heat to my already quite high body heat. Oh, I'm bright red.
Oh, brilliant.
Diatoms. Yes, focus. Diatoms. Getting distracted.
Yes. So I'd like to. So I should say how I found out about diatoms, and then I think hopefully that will segue into your stuff. So I was doing my undergrad project at university, and I found this fluffy stuff covering everything. It was looked like this little brown seaweed, and I went, being super keen undergrad, I was like, I need to do this identification on my own. I need to find this, and I went through. I think it's like a European seaweed site, and I went through every single seaweed on there. Like, it took a while, and I was like, it can't be that. And I got all these books from the library, and I went through all these books and couldn't pin down. And I was like, why can't I do this? And I went back to uni, because this was in summer, and I went back to uni, and within 30 seconds, one of the lecturers told me, this isn't a seaweed, this is actually microalgae, and this is diatoms. And when we got to see it, I was just blown away, and that was the first peek that I had into this world of I suppose it's the smaller rocky shore, the invisible rocky shore, which is so fascinating. So if you could say a bit more about, I suppose, how you found out about it, and just a bit more about it and how awesome it is.
Yeah, well, I mean, actually, I was quite lucky in the sense that marine diatoms weren't my first encounter with diatoms, because I think I would have been just as perplexed as you. And indeed, I have made similar mistakes with hydroids. And it was you, a wise one, who said, actually, not a plant. It is an animal. So I thank you for that. But I was getting water samples from the local canal where I used to live, which is nowhere near the sea. And that's where I first saw them. I didn't know what they were, obviously, but it was quite easy to find out what they were because it was fresh water. So we didn't have that extra thing of, oh, it could be a seaweed, it could be this. It was quite narrow as to what it could be. And I just thought they were the most beautiful things I'd ever seen. I thought they were absolutely glorious. And there's a couple of really great websites, ID websites. There's one run by the Natural History Museum Wales, and also one called diatoms.org, which is Diatoms of North America. But to be honest with you, they're kind of quite universal, quite a lot of them. So it became quite easy to start to identify them. The language I still find quite difficult because they use lots of scientific words, frustule and scepter and rafe, which we'll talk about in a little bit. And then I moved to the coast, and I knew there were marine diatoms, and obviously marine biology being my passion, being the thing that excites me, I was very excited to find some myself. And the rocky shore is a brilliant place because you get quite a lot of diatoms that bloom in the rocky shore, because the pools are lovely and warm, and the concentration of nutrients can get high as the water evaporates, I assume, and they kind of propagate, and just as you say, you can get so many diatoms that they look like seaweeds. And in fact, yesterday I went to the rock pools and I saw a brown fluffy seaweed. I'll take a sample of that. Lovely. Got home, diatoms. So even now, still, it's easy to mistake it for a plant, because some of the diatoms, they're sort of just by themselves, floating in the water, planktonic, and you get those, and that's exciting. But these ones that look like seaweeds, they're in these mucilage tubes.
Yes.
So there's all of these threads. I was looking at some only half an hour ago. All of these amazing threads, just packed, squeezed with all these diatoms. Absolutely incredible. And it excites me that you can see diatoms with the naked eye when they bloom. So you see brown sludge in a freshwater pond, and it just looks like sludge and it's disgusting, and you're like, well, that's really gross. And then you look under the microscope and it's these amazing yellow, golden, little crystally boxes of loveliness from this brown sludge.
I 100% agree with that. Like the micro world of and it's basically the brown sludge, but like diatoms and bacteria and everything are really important in what I kind of study as part of my research is biofoulings. The first thing that gets there is all these microorganisms, and they make it like super nice home for everything else to settle on. And it just looks like brown sludge. Like you come away, I feel really bad as well, because you come away covered in mud when you're like looking at these panels, and you just think you're covered in mud. And I'm thinking about it, oh no, how many have I got on my hands? I'm sorry. Washing them back in the sea, I don't know if that'll do anything.
Yeah. And it doesn't help that some of them move, which makes them even more, because essentially, I mean, they are algae. So, don't think twice about having a bit of a nori roll or whatever they're called, a bit of a sushi roll with a bit of seaweed on it. You see it as a plant almost. But because some of these diatoms could move, and under the microscope, that you in your mind you're going, that you're convinced that they're going dum, 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 and you anthropomorphize them so much, and you feel bad when you're wiping that slide clean. It's like, I'm so sorry.
I know, it's always I feel like everyone I meet always is like, oh, we shouldn't really anthropomorphize others. We do it too much, but then everyone does it. Like it's like I haven't met a single person yet that's gone, no, I never talk to the things I look at all the time. I don't do that. Everyone has to admit it just a little bit. So that I think we should just go for it. I think we should just be like, they all have tiny miniature voices, and they might all be in my head, but they all have them. So it's fine.
Absolutely. Yeah, no, I'm with you on that. Absolutely.
Yeah.
And I'm assuming, when you talk about biofouling, I'm assuming that diatoms are very much a foodstuffs for the things that you study, like barnacles and things.
Yeah, definitely. It's really frustrating, and we'll get more into, I'd love to hear about like how you take them and the microscope that you use, but there's a real divide, which is why I feel like I've skirted so close to diatom research for so long, but never got into it. And like I have, and I've seen them. I've got this nice microscope in the department that I use, and I've seen them under it, but it's not been part of my research because there's a massive gap in the literature between. There's these studies about the microfouling links in between, and just now with like genetic analysis and stuff, we're starting to see papers come out that are looking at like not the full genetics, but a big spectrum of genetic runs on panels, so that we can see what's living there, because they influence it. Like we know that's depending on what species of diatoms live there, like for the food and stuff, will entice different things, and being able to link that together, I think, would be really exciting. So I've been on the other side so far. I've been on the bigger end, even though that seems small to people. Like the barnacles are giant, they're so big. But compared to diatoms, they are massive. What do you know the size of the diatoms that you look at? Do you have like a scale at all, or?
Do you know what? I don't. That's on my birthday list.
Oh, nice.
But we're talking micrometers here.
Yes,
yeah. We're talking very small. I mean, you get quite large ones. I think they go up to about 0.5 millimeter, I think.
Yeah.
Which is pretty big. And then you get tiny ones that even when I'm using oil immersion at like times 1000, there's still these teeny tiny little things that I cannot make out what they are. So they do range quite a lot in shape and size.
Yeah, and I think maybe we should go and just say about like the tubes and things, because that's what I saw. I saw navicular, which I think hopefully you've got coming up as well, in these tubes.
Yes.
But in these tubes that you can see with your naked eye, because they look like fuzz or fluff or stuff, there's thousands. There's so many, and that's why you can see them, but you would never think that one strand. There's like a hair. It's like seeing like a hair in the water, but in that one hair could be like a million individuals of this diatom living together, like the hidden world that is there. I'd love if you could talk about how you take samples and the microscope you use, because that's part of the reason that this is so less known, because we are limited. You can't go rockpooling and just look at it and know. You have to bring them back and look in the microscope. But I'm sure there's plenty of people out there that would love to get their hands on having a look at it. So it'd be useful, I think, for people to hear how you do it.
Yeah, sure. I mean, I know there are some pretty insane techniques which experts always say is very simple. I don't think it's simple at all, where you actually collect diatoms and then you dry them out and you preserve them, and then you really look at the detail and really get down to IDing down to species level. I'm not at that point yet, but I do really enjoy looking at diatoms live, just because that golden color is just so spectacular, and I love to see them moving about. And I enjoy learning to recognize different I can never say it, genre of diatoms when they're living. So I can look at a sample and I can go, oh, that's a gyrosigma, or that's a navicular, or that's
it's a great feeling, right?
Oh, you feel so intelligent. It's lovely.
There's no one else in the room. You just say it to yourself, be like, I know.
Exactly. So when I'm on the rocky shore, Very often diatoms will come attached to other things I'm taking samples of. So if I'm taking a little tiny snippet of seaweed just so I can ID it under the microscope at home, often you'll have things attached to it, like Lichmophora or Grammatophora will be stuck with mucilage pads in chains or in groups or individually to seaweeds. So you get to see them that way. Alternatively, there's the brown sludge method. You learn to recognize when it's a diatom bloom. You kind of see the brown sludge or the scum, and you know that's going to be rich in diatoms. So you scoop it up and take it home. Even not on the rocky shore, even out on the shingle beach that I visit every day, where it's pretty devoid of life, big waves crashing. If there's an algae bloom, you can see the scum on the water, and I'll try and get soaking wet trying to get a sample in a teeny tiny little vial about that big, which is hilarious, just to see what's in it. And then I use a biological microscope, a compound microscope, just here. Let me just take off its clothes.
Oh, get in a nude microscope.
Can you see it there? There we go.
Yeah. Oh wow.
So that one's from Brunel. There, and it's one of the ones where you have a light that comes from the bottom and goes up. And really, you need to be able to see to at least 400 times 400, which is an optic at 40 and an eyepiece at 10. 10 times 40 is 400. I'm not very good at maths, by the way. I have to make sure I think about that. But I also use an oil immersion, which is times 100, which times 10 is times 1,000, which you have to use a special oil with because light does funny things at that sort of magnification. But most of the time, I just use times 400. I sound very boring.
No,
being very boring. I like to use a compound microscope.
I love that though. It's just science in your home. I think that's so cool. I'm just sitting here being like, I don't have a microscope in my house.
It is pretty epic, I gotta say. It
is cool. Yeah. And I feel like there's this, you're one of this is why social media is so great, is you're breaking down the stereotypes and the barriers that, science is this thing that's done off in far away labs with people in secret and that it needs all this fancy equipment. I would never be able to do that. But I know with this type of thing there is a barrier to being able to get a microscope. Not everyone has a microscope in their house, but really you once you've got the microscope you can do stuff, and it's people that have access to it sharing it for free like you're doing it's just amazing. It's great. And I have the microscope itch. I don't know if that's a thing. I'm like, I need one. I want that one now.
Sounds like you need a special ointment.
It does. It sounds a bit too medical. Maybe we should
like an eye infection. Doctor, I've got a microscope itch. Yeah, I mean, microscopes can be super expensive. You can get cheaper ones. I think it's a matter of I don't know, because this is the only microscope I've ever bought, apart from the stereo microscope that I bought the other day. But let's just stop talking about that. So this is the first microscope I bought. So it was a bit sort of, I read an amazing book, which I'll show you in a minute. It's made for kids, but it is so understandable and so it's excellent. I would recommend anyone who wants to get into microscopy, they should read it because it really makes sense. It's got loads of great exercises in it to help you get used to your microscope. But so I read reviews online and so on and so forth. But I think there are many more expert people who'd be able to advise on things like microscopes, budget microscopes and things, and Instagram as well. Such an amazing community. So I've had this microscope for maybe 1.5 years, 2 years, something like that. So not long, and it has been 100% Instagram. The people, the microscopists on there are so keen to help and so lovely, and not even in like a really patronizing way, like, oh, you're so stupid. Oh. They're just so lovely and so helpful, and you can just post and go, what is this? And people will go, oh, it's this. And then you go, why? And then they go, because of this, this, and this. And you get to find out resources and names of things, and you build up knowledge that way. And Instagram has been such an amazing teacher for me,
Yeah.
in both marine ecology and biology and in microscopy as well.
Oh, I love that. I think that's great. And like, I feel like it's been so important in that work, because you've had this microscope in the last year and a half, and the last year and a half, we've been at home and everything and all this, but it's so fantastic that people have just this amazing online world, which it's just been amazing. And I agree that the Instagram world is just fantastic to learn and everything. And it's the same, like it's the same level as looking at things like photography, where people, I never like photography. Like people, if you like photography, like cameras then can be insane amount, whereas you could just use your iPhone. There's different ranges of things, and and it's great to show people, maybe photography isn't for you, but if you like the photography of tiny itsy bitsy teeny weeny things, that's extra good as well, which is just really exciting to see.
Absolutely. And there are, not only are the people on Instagram really, really helpful, they're so talented. Like I could never take photographs like some of the people that I hang out with in the microscope world. Their stuff, like people like Tardy Babe and Postgraduate Procrastination and Microbe Guru, Awesome Algae, all these people are just, the stuff they post is just so dreamy. It's just gorgeous. So don't check me out. Check them out if you want to see diatoms and micro creatures to the max, turned up to 11, because they're amazing.
They are. It's difficult because I like, obviously I do lots of scientific art and everything, and I think that sometimes like the artwork itself is like beautiful, people painting them, but really I think diatoms might be one of the only things I'm like, actually, like the real life photo of this thing is like, I don't even know if you could paint it better. Like usually I'm of the mindset that like a great painting can always improve something, even if you've taken a fantastic photograph, but like the actual, because you can't believe that's real, it looks like a masterpiece. It's like nature creating better art than humans could ever create. I'm sure everyone could do a wonderful picture of it, but the fact that nature has made that and that you can photograph the artwork itself is just like, oh, okay, you win, nature, I'll let you have that one.
Absolutely. And in Victorian times, I can't remember exactly what it's called, but in Victorian times, it used to be a bit of a trend to create art with diatoms. So people, blokes usually, they would get diatoms, they would cure them, and they would kill them and all those sorts of things, and then with pipettes or whatever, they would arrange them in these amazing sort of mandalas of different diatom species, and you can buy you can buy from antique places and stuff these Victorian slides with these works of art made from diatoms. It's nuts. It's so beautiful, and I would never have the patience to do it, but it's absolutely stunning stuff.
Yeah, it'd be one of those things that you look at and you go, I'd love to, and you get around to doing it and you sneeze and then that's it, I'm done. Like I'm fed up.
Exactly.
Ruined it in a second.
Exactly. Under the microscope, I'm like trying to look at something under the dissecting microscope, and I'm like, whoa, whoa. No good at it. The tiny stuff.
I know. Oh yeah, it is difficult. Microscope is definitely a skill. Like moving something without, feeling like you're punching something. It's very bizarre skill. We're getting very specific with our our thing. Oh, that's so cool.
Your girl's patch, by the way, that is awesome.
Yes. Oh, opposite way. I put it on slightly wonky, so now I have to do like a power pose for it to be straight. I'm like, yes. Who runs the world? Girls. When I do this,
perfect. What have you got on your t-shirt?
I got
that looks like some kind of crustacean.
Yes, I've got a nice lobster. I've also got Mr. SpongeBob. Lots of badges. This was my birthday present recently. I decided that I didn't want anything, but I wanted a kitted out badge jacket. Not anything.
Awesome.
That's what I was like, everyone send me. I've got a jacket. Send me tiny things to stick on them.
Fantastic. I'll remember that. Let me know when your birthday is. Send a little something in the post, perhaps. Diatoms. We're digressing. So they are algae. So they are the same sort of family as your seaweeds. which is kind of incredible to believe because they don't look like seaweed. But of course, algae comes in all sorts of different shapes and sizes. You know, you've got little green things that wiggle around and, you know, have flagella and all sorts of things. But they're these beautiful golden colour. So like algae, well, not like algae because they are algae, they photosynthesize. So the yellow, the goldness is the plastids within inside. And they're eukaryotes. So they have membrane-bound organelles, nucleus, and so on. And one of those organelles is these plastids, which contain the chloroplasts, which photosynthesize. So diatoms obviously need to be in an area where they can get sunlight. You can get them planktonic, so floating around. You can get them benthic as well, so lying on substrates or in muds or sands. As long as they've got access to light, they're happy. What else can I tell you about them? Yeah, so they're more in the sea. They're more prevalent on the coast because they've got the nutrients there. So very often from runoff and things, and also the minerals, again from runoff or from, you know, the crumbling cliffs and so on, which provide them with the materials to build their shell. So they have an outside shell called a frustule, which is made of silica, and it's like glass. It is like glass, and it's see-through like glass. And this glass frustule, it's made of two parts. In fact, I can do a demonstration.
Oh, it's getting sciencey now.
A bit wet. They fit together a bit like a petri dish. So you've got a larger, so these two parts, they're called valves on a diatom. So the frustule is made of two valves, one bigger, one smaller, which fits over the top. Oh, that's the bigger one. Fits over the top of the smaller one. And where it meets is called the girdle. And you can look at diatoms under the microscope in valve view. So with a centric diatom, which will be a diatom that has radial symmetry, you can look at it in valve view where it looks like a big circle, or you can look at it in girdle view where it's going to look like a rectangle, which is really interesting because very often you can see the same diatom species in the same sample but think it's two different diatoms because you're looking at them in two different angles, which is kind of interesting. But yeah, so you get centric diatoms, which have this radial symmetry. You also get pennate diatoms as well, which are more like okay, so they're sort of more sticky, but they come in so many different shapes, all sorts of wonderful shapes. You've got the Ondontella. Hope I'm saying that right because I'm doing it from memory, which is just so ornate, and they join together in these beautiful chains. They sort of look like spiky pillows. And then you've got Plurisigma, which is sort of six lines and spikes, and ones that are like rolls of coins, and just all manner of shapes that you can think of. Yeah, I like diatoms. I don't know if you can tell.
I mean, this is the point at which if you like, I don't really like them now, actually, I'd be like, whoa, I'm glad you did. You just come around and say like, oh, no, I'm not that fussed now. Like, oh.
They're really boring, actually. No, they're pretty awesome. And they're really important. They're really, really important. I should make this point. By point, I should do my politician thing. They're really, really important because not only are they food, so they're primary producers right at the bottom of the food chain. So if they didn't exist, lots of things would starve and die. So they're really, really important. But they also are great carbon sinks. So they take in a lot of carbon dioxide, and I think it's 20% they take global carbon. So they're really, really important for that as well. They can also use in forensics, which I find absolutely fascinating. So obviously, if they've got a victim that's drowned, for example, they can look in the liquid that they've inhaled, and if there's particular species of diatoms in there, then they can start to pinpoint perhaps where that accident or that crime occurred because they can match diatoms.
Yeah, that's really cool. I don't know where I listened to it or heard or read a paper on or something, but it was something similar about like biofouling on on for forensics and at working out where things have been and how long they've been in the sea and everything, which I just think is really interesting. The alternative route that we could go down in careers. There's definitely a detective novel in there of the marine biologist turned murder mystery.
For sure, for sure. That actually, for a lot of my life, I wanted to be a forensic pathologist. So maybe in the future, my two worlds will collide.
There we go. Literally anything can happen. I feel like that's going to happen. I feel like that just seems too cool not to for you not to like eventually end up there.
It does, doesn't it? I'm gonna make a note of that.
Yeah. Post-it note, stick it on the wall. That's how it happens.
New ambition.
Oh, that's so cool. What is the best, prettiest, most surprising, thing that sticks in your mind the most when it comes to finding diatoms, and that you found?
That sticks in my mind was seeing my first algae bloom. Actually, it wasn't marine; it was freshwater. It was on a beach though, and again, it was this whole thing of just seeing this disgusting sludge and taking it home and looking at it under the microscope and just going boom. And it was this diatom called Melicera, which is a centric diatom. They're like little Tic Tacs, but they all stick together in a. Well, you get different sorts of Melicera, sort of some that are more like £1 coins, and then you get other ones that are like Tic Tacs. But they all come together in these massive, great big chains. And just seeing that and not realizing that you could see diatoms with your naked eye if they bloomed, if they proliferated so much that there were so many of them that you could actually see them. You could actually point and go, those are diatoms, even though they're microscopic. And that absolutely amazed me. And then the other thing that I absolutely adore is just grab yourself a cup of tea. Come on. Yes, I know. Ah, yes. Oh, I was right. No, I wasn't. Odontella. Odontella is, and hopefully there'll be a photograph like there or something, I don't know, are these gorgeous little pillows, which I absolutely adore. They're so stunning. And they've got sort of like little stars in the center. They're just glorious. But it's the variety of shapes that constantly surprises me. Some of them, I've got to admit, some of them are a little bit boring. They're just like a little needle or a little rectangle. And there's so many of them that you just kind of almost not see them every time you look under the microscope. But occasionally you'll get, and then occasionally you'll get this one that just looks so different and so ornate or such a beautiful shape that you're just like, oh. There's one a freshwater species called, I can't remember, but it basically looks like the form of a woman. It's just such a sensual shape, which is so weird because it's an algae, but it is such a sensual shape. It's absolutely beautiful. I have to try and remember what it's called, but can't remember. Gomphomina. Absolutely beautiful. At the time, diatoms, they binary fission. They divide basically. So if you think about, get my petri dish again. There it is. So a diatom its valves will separate, and then a new valve will be created on the inside of each parent valve, making two new daughter frustules. Now, the problem is that quite a lot of those are going to get smaller and smaller and smaller because the valve that gets made is the smaller one. So diatoms will get smaller and smaller and smaller the more they divide. But they'll get to a point where they're too small to divide anymore. So then sexual reproduction occurs, and they make these amazing things called oxospores, where the diatom will sort of swell. They make a shell made of I think it's a sort of a softer material, and it swells, and inside a new frustule is made to the maximum size of that species, and then once that's created, it can then go on to asexually reproduce again, and the whole thing starts again. They can also have a resting state as well, so they have like a what's it called? Is it statospore, where they can just hang out until the conditions improve for them, which is
that's so clever.
It's pretty nice if you can do that. Not bad.
It's like backwards. They're literally like it's I suppose because you're not shrinking, because you're also, I'm just thinking that we grow but they shrink, but it's not quite the same because they're reproducing smaller. But that's just, it seems like the opposite way to what things usually do. Like fish always do better reproduction when they're bigger and everything, but they're like, nope, we're going to get smaller. And then, well, that's really, really fascinating.
Yeah, I found that book, The Ultimate Guide to Your Microscope. Like I say, it is for kids pretty much, but it makes complete sense, and it's got all of these little projects in it that you can do that help you learn how to use a microscope, how to prepare a slide. I mean, one of the coolest things to do when you first get a microscope is to do your own blood. Obviously, don't go and hurt yourself, but if you knock your finger or something, and you just now every time someone has an accident in this house, I'm like, wait a minute, let me just get a slide. And seeing blood cells under the microscope is just so cool, especially your own. You're like, whoa, that's in me. It's like a rite of passage, I think.
Oh, that sounds really cool. Yeah, and it is useful because the first time I was in front of a microscope, I had no idea what was going on. Like, I remember the first undergrad practical I did where I was just like plonked in front of this fancy microscope and told to like get on with it, and I was like, and then the point of it was, the whole practical was getting used to it. But so it's actually really good to have like a simple handy book that you can look through, because it's not as simple as it seems. You seem like it should just be, put it on it, look through the eyepiece, but it's like lining it all up and like the focus of things and the different microscopes bits for different things. It's very much much more complicated than it seems, and it kind of makes sense. You're still trying to see tiny things that are giant, but making them giant. So this is not, as easy as a magnifying glass.
It's really technical. It's a bit like photography. I used to be a photographer, and I've never been a very techie person. And of course, you get people in photography and you get people in microscopy who are really technical and really tech savvy. And they know exactly how the physics of it all, how the light works, and the different sorts of bits of equipment that you could use for this, that, and the other. I don't understand any of that. For me, it was literally kind of trial and error, because you've got to balance things between various parts to get the right sort of light and to get the right sort of contrast. And thicker things are going to need a different sort of light to thin things, and all of these stuff. But I think with most things, it's just doing and experimenting and see what works and what doesn't work, and watching other people do stuff and learning from them. But yeah, I find the technical stuff terribly complicated. My gurus my mentors on Instagram will be terribly shocked, but I don't I don't get most of it. I just like looking at the little creatures going doo-doo-doo. I am just a beginner in this. I've only been looking at diatoms for, like I say, about 2 years. And there are people out there, especially on Instagram, and there are books and websites which are much more informed than I am. So if you're interested in diatoms, go and check those out. And and enjoy the magical world of diatoms. They're absolutely beautiful. If you want a little bit of taste of if you want a bit of taste, if you want to have a taste of what diatoms look like, I know that Elizabeth, you'll be sharing a couple of photographs during this conflab, but you can also follow me on Instagram at Elizabeth Beston. I do a combo of microscopy stuff and also marine biology stuff as well. So come to the Instagram page, which is shown beautifully on screen there, and yeah, come see what I'm up to. Come talk to me. Come ask questions, and I will reply to them, probably saying I have no idea, but I'll try and find out for you, as any good scientist.
Yeah, it is fantastic. I mean, I thoroughly enjoy getting to see all the stuff that you're learning about and learning and commenting, and it is really fun. So anyone interested in marine biology, UK coastlines, just fab microscopy stuff, ponds, everything. If it's near water and sciencey, Elizabeth is there. It's just great. So you should definitely go check that out. Well, I hope everyone has enjoyed this conversation. I've had a blast learning more about diatoms and getting to see them. And I hope this is kind of the start of people's realization that diatoms exist and their journeys, and share with Elizabeth's Instagram and mine. I'll chuck mine up there. I'd love to see if anyone goes out and goes diatom hunting. That makes it sound far more extreme than than it probably is. Yeah, that sounds like a proper American documentary series, shouldn't it? It should be like Diatom Hunters, like gold pickers.
Killer diatoms of the North Atlantic.
In the cold, they wrestled the dark cold to find the tiny glass. Well, you'll see us on that TV show soon, but you're yeah, if you go out and find some diet, we'd love to see it. It would be fantastic, and I wish you all the best of luck to everyone watching, and to Elizabeth for finding some more extra awesome cool stuff. So thank you so much for coming on my channel and giving up your time. It's fantastic talk.
Thank you very much for having me and inviting me. It has been lovely to have a conversation with Elizabeth 1.0. Really, I should be Elizabeth 1.0 because I was born like way before you. But then I suspect some other Elizabeths were probably born before me. So I should probably be about Elizabeth 3.7 million, maybe.
I think what we should do if you come back to the channel and chat again is I'll get a record from the registry or wherever it is of all of the Elizabeths that have ever existed in the world ever, and we will work out our specific ranks and move forward from there. I will, or alternatively, we just don't have to number ourselves, and really I should have started with that. I mean, either way, whichever one I go with, I'll let you know. Probable Elizabeth 2021.
Well, it'll soon be easy because, of course, eventually, very shortly, I'm sure, you will be Dr. Elizabeth. And I can refer to you as the doctor.
Oh, that would be cool. Awesome. Well, thank you for coming on. Cool.
Bye.
That's the